Okay, good morning, everyone. Today we're going to begin our discussion of a very important topic in finance, which is finance machine learning. Okay, may I know, class, if you have in your other subjects you discussed this or you learned about this, or did you have any other subject where you did some let's say modeling in machine learning? Yes or no, please. I just would like to know if this was discussed in your other subjects. No, thank you, Jay. Okay. All right, good. Because this is an opportunity for us to learn. Okay. If you had other subjects that discuss this, I hope it's not just a replication. But you told me before that you were not really focusing on R. So this is machine learning where we focus on R. I have provided the most of the notes, but of course this should not deter you in sourcing out other information. It's important that you know that I cannot really put everything here in this file. So the internet is awash with so many information about machine learning because uh, it has been here for a few decades, and this field has really become more developed over the years. That's why there are already many softwares that deal with this. And since we're using R, and we know how R has also been, let's say, its capability has been increasing over the years because of so many contributors, so many who make use of this software, then really this tool is very apt and capable of doing machine learning models. So it's important, I'm sorry about the spelling, what this module, uh, what we will be discussing in this module. We're going to study some of the methods used in machine learning in the context of finance. Okay, so since our course is finance, we will mostly make use of machine learning in finance. What we're going to do is we're going to use a simple data, and then we're going to do machine learning using different methods and try to compare which of the methods uh, perform better for this particular data. Now, we're not saying that the result of this lesson allows us to conclude that this particular method is best for all data. That's not true. Uh, there are some basic methods, models that use, for example, decision tree and random forest. Compared to the other methods, they're, shall we say, more basic. Okay. All right. So what we're going to focus on is stock price movements, which is a typical or a favorite topic in finance. Hopefully, by the end of this module, we will be able to uh, perform some activities that are related to machine learning. So we're going to implement using the different methods, five methods. Five of the most, let's say, common methods that's used in thesis. Okay, so many theses have been uh, developed or have been submitted by students using these methodologies. And perhaps in the future, when you go to your thesis, you might be interested to make use of these methods. And we hope that in this subject you had a not really that in-depth, but at least a taste. At least you have a know-how of how to make use of machine learning in modeling data. So we're going to implement those five models. And then this is very important, training and testing. So what's training and testing? When you have your data, okay, you do not use all your data in order to model. If, for example, you're going to predict stock prices, what we do usually is to split your data into two or three, usually two. Okay, so why is the data split? The data is split because we don't want uh, to suffer from what we call overfitting. Okay, overfitting. Overfitting, okay, means that you use all your data to come up with the model. So what will happen is that it's possible that the model that you created is fitted for that specific data, so that if a new data comes in and you try to make use of that model to let's say predict using the additional information, then the prediction might not work or it might not be good because you have created the model that specifically let's specifically uh, created for that specific set of data. So what happens is that if you have this data, okay, we usually split it. Okay, we usually split it into two, and then what we do is we make use of this data, which is oftentimes called your training data. You use this data to come up with your model, and then you try to see if your model will work with this testing data. Okay. Again, this is used in machine learning purposes. Why? Because we don't want to use the entirety of your data because it might create what we call overfitting. Okay, overfitting. Okay, so we would want to be splitting our data so that we don't create an overfitted model. Okay, so that's one of the things that we're going to do here. We'll have a very easily accessible data, for example, stock price of any company. And then we're going to predict the prices, okay, using machine learning. We're going to use at least 5 machine learning methods. And we're going to train our data to come up with a model. And then whatever model we generate from the trained data set, we're going to test if it will work with the testing data set. Okay, and then we're going to evaluate at least 5 machine learning models using a real financial data set. Okay, all right. So in the context of finance, what's the purpose of machine learning? Well, it's used for several reasons, and one of the reasons that I mentioned is that it's used to make predictions. Okay, and it's also used to detect fraud. And machine learning has been used by to create models that might predict fraud in a particular transaction. And also machine learning can also be used for optimization of portfolios. What we did last time, portfolio optimization, we did not actually use machine learning for that. We used the usual. Okay, I didn't want to burden you so much with two different concepts, portfolio optimization and machine learning at the same time. So that's why I split it. But you can do portfolio optimization using machine learning. And another use of machine learning is to automate trading. Okay, which means that you let your computer do compute for signals for you to buy or to sell, depending on your objectives. All right. So these are the 5 methods that we're going to use. These are very popular ML algorithms. Okay, when I say ML, I mean machine learning. So we have decision trees, we have random forest, we have support vector machines, we have XGBoost, and you have artificial neural networks. Of course, we won't be able to discuss everything in one sitting. So maybe we'll be able to begin at least with, I don't know if we can reach up to decision trees, but it's okay. We'll be able to cover all of this. And at the end, okay, so as I said, we're going to use one data set. And then at the end, what we're going to do is to compare the performance of these different algorithms, decision trees, random forest, support vector machines, XGBoost, and ANN's artificial neural network, in order to test which of these performed better as regards the objective of predicting stock prices. Okay. Now, as I said, we cannot overly conclude that since if in case ANN, let's say ANN, performed best with this with the prediction of this particular stock, we cannot say that it's it will be it will be ANN that will predict other stocks better. Okay, it's a case-to-case basis. Okay, so what will be our objectives? Okay, we're going to use Apple, a very popular, very basic data. Okay, and we're going to learn how to pre-process it. We'll have an example, not today, but next meeting. I'm going to give you an example where you have data where there are missing values. In your thesis, you will encounter that. You draw out data from different sources, and you notice that some of the data are missing. So what do we do with that? Before you even begin to create a model, there has to be proper cleaning of the data. Okay, proper cleaning of the data. So that's what we mean by pre-processing. And then we're going to create features. Features are also variables that can be used in order to that can be used in your model. For example, the field of this is called feature engineering. Okay, example, when you download Apple prices, okay, you will not have the moving average data there. You will not have simple moving average, exponential moving average, or RSIs or Bollinger Bands. Okay, you can compute for this metrics and then use it in your model. That's what we call feature engineering. So you're creating data out of your data, and then you're going to use it for your model. So that's creating features. And then, as I said a while ago, we're going to split our data into training data and testing data. So we're going to use the trained data set in order to predict stock prices. And then we're also going to use the model that we created to test if it works with the test data set. Okay, we're going to evaluate then these models using metrics like Ramsey, accuracy, R squared, and there are other metrics. But for a quantitative data, Ramsey, accuracy, R squared, or maybe you can include here mean absolute error, okay, mean absolute percentage error, MAPE. These are metrics that are used in order to assess the performance of your stock. And then once we have run the model in all the algorithms, then we select the best performing model, okay, for this particular data set. Okay, again, we're not concluding that this is true for all the others. Okay, so what is machine learning? Okay, at its very core, when we talk about machine learning, it is the use of algorithms so that it allows the computers to learn patterns in your data, and from there, from learning patterns from your data, to make predictions about it. Okay, so it's like training your computer to learn from your data, and then continuously learning from your data to make certain conclusions about it. Maybe you have heard that, well, actually machine learning is part of AI, artificial intelligence. Okay, and the objective here is that you have large data sets, and then you use ML algorithms, machine learning algorithms, in order to find insights about your data. As I mentioned a while ago, machine learning has many roles, many applications in finance. Okay, so I mentioned before what were the examples. Okay, so as I said, for detecting fraud, optimizing portfolio, and among many others. Okay, so there are different types of machine learning. Okay, you have supervised learning, which is what we're going to apply. This is the most common approach in finance. So what happens with the supervised learning? As the name suggests, supervised, you have your data, and your data is labeled. Okay, you have labels about your data. I mean, for example, if you download stock prices, you know that this data is the opening price, high, low, close, volume adjusted. Okay. So what we're going to do in this subject is we're going to split our data, and then we're going to use this historical data in order to predict the price for the next day. Okay. The task of machine learning algorithm is to generalize. Okay. Once we use this training data, it will generalize and come up with a model that will predict the price the next day. Okay. Uh, there can be, okay, so for supervised, it can be regression type, or it can also be classification type. What's the difference between the two? If it's a regression type, you are predicting the value itself. So you have your data, and then you'd like to predict the price. For classification type, okay, you're interested not in the price, but if the price, let's say, if the price will go up or if the price will go down the following day. Or if you're looking at returns, if the returns will go up or the returns will go down or the returns will remain the same. So the difference between those two lie in the objective. The first one, for the first one, the objective is to predict the price. Okay, so the variable that you're predicting is quantitative. Okay, so that's what we call the regression type of supervised learning. On the other hand, if what you're predicting is, let's say, categorical. So for example, you have data and you'd like to predict whether this will be fraudulent or not. Okay, you have this particular transaction with the different features, the different variables, the different data, the different features. Then you'd like to predict whether this particular transaction is fraudulent or not. In that case, then that type of machine learning will be what we call classification. So it's just like binary logistic regression. So you can, in other fields, for example, in the medical fields, you have several features. Let's say you'd like to predict whether a person has diabetes or is prone to heart attack, okay, or has a heart disease. Then machine learning can do the thing. Okay, so you have several variables there, say BP, let's say blood sugar, and other metrics. Then given this, we'd like to determine if this person has a potential heart condition or not. Okay, in that case, that is also an example of supervised learning, but for what you're using is classification. That's why sometimes, okay, it can be called CART, which is classification and regression trees. This is for the first algorithm, which is decision tree. Okay, classification or regression. So for classification, we are attempting to classify a particular observation. We're in it. Is it this or that? Okay, you're classifying it. On the other hand, regression calls for predicting. This is a quantitative thing. This is a categorical thing. Classification, as the name suggests, you're classifying it whether it's whether, just like in the example that we had before, the binary logistic, whether the student will be admitted or not. Okay, if you're going to model that using machine learning, then that's a classification, an example of classification learning. Okay. Now, unsupervised learning is more difficult. Okay, because here you'd like to make sense of certain patterns. Okay, for example, you're using marketing data, so you have several how do I call it, attributes, and then you'd like to see if there's a pattern between your data, so that you can also classify it. Okay, So this time you'd like to identify clusters. Notice that this is unsupervised. Okay, so this is used for segmentation. For example, you have you have several respondents, you have several data about individuals, and then you run the data using unsupervised learning. You'd like to classify this group of respondents belong to this group. This particular respondents belong to another group, and then you try to see what's common among these groups. Okay, so that's what we call unsupervised learning. Okay, the most difficult of all is reinforcement learning. Okay, an example of that in finance is algorithmic trading. So this is more complex, and then this will require really uh, high-powered computers. Okay, so in this module, we'll focus on supervised learning. Okay, as I said, a good example of supervised learning in finance is you predict the stock price. So we're going to use Apple, given the historical price of Apple. The goal that we will set is to predict the price of the stock on the next day, based on features that we're going to use, based on previous day's price, and we will also be creating features like moving averages and maybe perhaps trading volume. As I said, we're going to train the model based on past data so that we have accurate predictions on future data. Okay, so let's now go to our data. Okay, so when we download data from using quant mode, we will have stock prices, or in other sources you can download currency exchange prices or commodity prices. Now, from your other subjects, I hope you have heard that time series data is quite unique as compared to cross-sectional data. For cross-sectional data, it doesn't matter. Okay, so for example, let me illustrate that. Okay, you have this cross-sectional data. Okay, you have different countries. Okay, maybe it's arranged alphabetically, and you'd like to split this into a training data set and a testing data set. Okay, what's normally done is to break the logical order. If this was arranged alphabetically, so what you can do is to use R in order to change the order, and then randomly. Okay, for example, if this if this data has an index, let's say 1 up to 100, so I'll arrange alphabetically. So let's say these are 100 countries. So what will happen now is this will be rumbled, jumbled. Okay, so that number 1 will now be a different country. Let's say it becomes Bosnia. Okay, or number 5 now becomes, whereas let's say that before it was Azerbaijan, for example, now it's let's say UK. So what was done was to change the order. Okay, change the order of the countries, and then after the order is changed, what we can do is, let's say from 1 to 80, that will be your training data set. Train, and then from 81 to 100, that will be your testing. Okay, this is fine. This is okay because you have originally removed a logical order, let's say alphabetical order, or let's say there is a order, let's like it's by continent. Okay, so there's a possibility that if you did not change the order and then you took 1 to 80, it's possible that, let's say, by continent, first is Africa. So you have all the African countries together, and that can be part of this training data set. Okay, and then the other continents, it will become part of the training data set, and that's bad because you now place some countries that might have similar characteristics in one. Okay, so what's important is that this should be any logical order of this data should be removed so that it becomes random. Okay, so now that we have random order of this, what can be done is, again, take some portions of this randomly again. So that's also a good way to split your data into training and testing. So I hope that do I make sense, class? May I have your comments if I'm making sense in the process of splitting your data into a training data set and into a testing data set. Before you split your data, you will have to make sure that it's not logically arranged. Okay, because there might be a danger if you split it. Let's say the first 80 should form part of your training data set. And if this was logically arranged, then you'll have a training data set where the data here would be related to each other one way or another. Okay, and your testing data set will also have relationships among themselves. Okay, once again, may I class ask if my explanation is clear? Okay, thank you. All right. How about the others, please? If it made sense, if you didn't get it, class, it's okay for you to ask me for clarifications. Okay, good. Thank you so much. So this is cross-sectional data. Now, how about time series data? Where you have temporal, there is this the presence of temporal arrangement. So for example, it's based on dates. Okay, let's say from 2015 January up to 2024 December 2024. Unlike in cross-sectional data, you cannot just reorder this. Okay, you can't make 2023 January 15 as the first observation. And then the last observation will be 2015 May 5. That cannot be, class. That cannot be because of the temporal order. When you have a time series, there is order in your data. Okay, so there's a different way to split your data into training and testing without changing the temporal order. Okay, so in this case, maybe we can split our data, depends on your objective. Maybe we can split our data from 2015 to 2023, for example, only. Okay, and then our testing data will be 2024. Okay, is that correct? Yes, that's correct. Okay, because you're not destroying the temporal order of your data. Okay, and it's different from your cross-sectional data. Okay, and there are other methods. This is one of the most common ones. Okay, so since we cannot destroy the order of your data, then we will have to split somewhere. Okay, there are other methods which we're going to discuss later on. Okay. All right. So as I said, time series data is different from your cross-sectional data, from your standard tabular data, because the order of the rows in a standard tabular data does not matter. If you have a cross-sectional data, then the order of the rows doesn't matter. You can jumble your data set in any way you want. You can create in R, there are many ways to do this. You can reorder your data in such a way that it destroys the original logical order of the data. Okay? And then there are key challenges also as far as time series is concerned. This is not present in cross-sectional data, the autocorrelation. Since your time series is logically ordered, it has a temporal order to it, then there's a possibility that your time series data is correlated with each other. The let's say prices on January 5, 2024 is related to the price on January 4, 2024 or January 6, 2024. There may be autocorrelation where the data is correlated with itself. So the price today, okay, was related to yesterday's price, and it may have a direct effect on tomorrow's price. And as you have learned in the past, this is autocorrelation. Also, okay, if you have studied time series before, you must have met the concept of stationarity. We did, of course, in this subject. We talked about stationarity when we talked about ARIMA. Okay, so many machine learning algorithms will assume that our time series data have properties of constant mean and constant variance. Okay, in other words, they are stationary. But truth be told, that oftentimes time series data are not stationary. Okay, so another challenge, which I mentioned already, is how do we split our data? Okay, because if it's cross-sectional data, we can split the data randomly, split it into training and testing. For time series, that cannot be. We cannot split the data randomly. It's not appropriate. Okay, it's not appropriate. So the data need to be split chronologically. All right, so for this activity, okay, we're going to use Apple stock prices, as I said, and then we're going to predict Apple stock prices using the 5 different machine learning models: random decision trees, random forest, support vector machines, XGBoost, and your ANN, artificial neural network. So we can access data from Yahoo Finance, open, high, low, close, even adjusted. Sorry, I forgot to put adjusted here. Okay, so after we have downloaded the data, we can do what we call feature engineering. Feature engineering means we create other variables that can help us predict stock prices. And what are these variables? We can create moving averages. Okay. Quant mode and TTR, technical trading rules, in R have a great capacity. Okay, let's just okay, maybe let's take a look at this one from the packages. We have downloaded this in the past. Okay, let me just show you, class. TTR here. Just click this first, and then let's see. Okay, you can see here, if I'm not mistaken, I think I showed this to you before. You have the average 2 range, Bollinger Bands, commodity channel index. Okay, you have RSI, relative strength index. You have MACD, moving average, convergence, divergence. Okay, ROC, rate of change. Okay, you have SMA, moving average. You have EMA, exponential moving average. You have several metrics here that we can use, that we can compute, that we can include as a feature. Okay, when we say feature, this variable we can incorporate in our data, and we can make use of it in order to predict our stock price. Okay, so at our disposal are many metrics, okay, that we can use to predict the stock price. Okay, so I mentioned here some of the features that we can use. We have moving average, you have RSI, you have MACD, moving average, convergence, divergence. Okay, this is a momentum oscillator. You have Bollinger Bands, you have stochastic oscillator, EMA, exponential moving average, etc. Okay, so you have a lot of metrics. So for this exercise, we'll just use 2. We'll just use MA and RSI. Now, the most common ones, okay, the staples, I would say, are these four plus others, but these are the most common ones. MA, EMA sometimes, RSI, MACD, and Bollinger Bands. They're staples in financial modeling. There are also those that are volume-bound indicators, okay, like ATR, average true rate. Okay. Now the choice of the features, the choice of the metric that can be used for trading strategy will of course depend on your strategy, the market conditions, and other factors to be considered. Okay. Now, as I said, I'll be giving an example of this, especially handling missing values. I'll give an example of a data, okay, and actually these are real data. Okay, I'll just show an example where uh, I have some advices. They had difficulty. This was before they had difficulty with the data because there were so many missing values, and we discussed how this can be addressed. And one of the way to address it is the LOCF, last observation carried forward. Okay, because you cannot work on a data that has missing values. Okay, so that's why this is a very important part of machine learning. You have to clean your data. You have to check your data. You cannot just work on data that has missing values. Okay, and then this one, as I said, feature engineering. Okay, including some metrics that we can use in order to model our data. And sometimes there are metrics, for example, for SVMs, support vector machines, and neural networks. We need to scale our data. So we cannot use the stock prices, but we have to scale your stock prices as to numbers between 0 and 1. Okay, just like normalizing your data. Okay, so those are very important steps when we use SVMs or neural networks. All right, so let's go to downloading our data. So we have here, we're going to use quant mode, TTR, and tidyverse. May I request the class to please load this? I have already loaded this, so I won't. Anyway, I'll remove the data here. Okay, and then I'll run this also. We have loaded these packages in the past, so I don't think there should be any problem. All right, then let's make use of a quant mode. Let's get symbols for Apple. Let's make it from 2015 up to systems date, up to today, March 24, trading yesterday. And then we will be creating an object called data. Okay. Apple, as you know, will be an XTS object, but we will convert the XTS object, the Apple data, and create a new one called data, and it should be as a data frame. Okay, so let's run this. Okay, so we now have Apple. So you see that this is an XTS object. For data, okay, this is just a data frame. Okay, notice that it's not an XTS object. If we check, okay, let's check the structure. Control Alt I, structure of AAPL. You know the answer here, class? It's an XTS object. While on the other hand, the structure of data, this is, okay, this is a data frame. Okay, the reason why we're converting it into a data frame because of computational requirements, which we're going to see as we go along. Okay, are we okay so far, class? May I know if you were able to download Apple? May I have your comments, please? I hope I'm not going too fast, class. Just enough for us to have our bases covered for all our topics. Waiting for your response, class. Okay, good. All right. So let's start with moving average. Okay. Moving average, there are two types of moving average. You have your uh, simple moving average, and then you have your exponential moving average. So it's a widely used statistical method in technical analysis. The purpose of moving average is to smooth out your data. Okay, if we try to plot, let's see if we can plot see data, see the closing. Let's plot the closing data of Apple. Okay, plots here, there. So this is our data. Okay, you can see that there are, although there doesn't seem to be any seasonality, but you can see that there are ups and downs of behavior here. Okay, so when you use moving averages, it tries to come up with a model of your data that removes these ups and downs. Okay, of course, depending on the lag, depending on the lag. If you're my student in time series in art, fin arts, then we discussed this last time, moving averages. Okay, so okay. The formula for simple moving average I have provided here. Okay, unfortunately, my LaTeX does not seem to work. May I know, class, if you have the formula for LaTeX here? Double to. Maybe that's the reason. Okay, double. Well, it's okay. Uh, can you kindly, class, tell me if you were able to run the LaTeX code for SMA? Yes or no, please? Good. Okay. Good. In my case, I don't know what happened, but maybe I can flash the one that I used for. Okay. See here. There. It's running in my other R, R Markdown, but in the machine learning, it was not. So it's just, class, simple moving average. You just identify your lag, okay? And then you just get the average. This is just sum of your y sub I divided by k. Okay, so for example, it's a 10-day moving average. So what you do is you sum up your value, your price at day 1 up to day 10, and then divide it by 10. So the first figure for your simple moving average will be day 10, okay? And it will equal to your prices for the past 10 days divided by 10. So it's just a simple average. Here you have your K, okay? So if it's a 5-year moving average, simple moving average, then you add your stock prices for 5 days, okay? And then divided by 5. Okay, simply put, if let me okay, let me show our AAPL Apple object. Okay, view. Okay, here. So yeah, here. Suppose I'm using Apple prices. So SMA5 class means what you do is to get the 5 prices, 1, 2, 3, 4, 5. Okay, get these 5 prices, and then divided by 5. So that will be your SMA5 on day 5. And then on day 6, it will be from day 2 up to day 6. So five values again. Okay, you just keep on moving forward. Okay, so that will be your uh, the value of your uh, closing price on day 6. Okay, because you just keep moving forward, get the average of 1 to 5, get the average of 2 to 6, get the average of 3 to 7. So that's your simple moving average. Okay, so let me go back. Okay. Okay. So now let's create a, this is now class creating feature. What do we mean by creating feature? We're going to include a metric, in this case, a moving average and moving average 20. So we're going to use the function roll mean. It means that you're getting the averages and you're rolling it 1 to 5 and then 2 to 6 and then 3 to 7. That's what we mean by roll mean. Okay. All right. And then for this is 20 days. Okay. 20 days and fill is equal to NA. We're not going to fill. We're going to just use the regular 1 to 20. Okay. And then 2 to 21 and then 3 to 22. Okay. So let's run this. And take note, it's under data. We're creating this column MA underscore 20. Okay, so I hope you understand this. We have this data. Okay, this is our data object. It's just like your Apple. Okay, the only difference is that Apple is an XS object, while data is a data frame. Okay, so let's go back here. Okay, where's our, this is our file. Okay, roll mean, then data. Okay, which variable of data are we going to use in order to compute for the 20-day moving average? It's the Apple close. Okay, and then if you run this, run it, and then if you check your data, what happened to your data? You now have a new variable. Okay, new variable class 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, you notice that. Okay, why is it on the 10th day? This is a rolling mean. Why is it on the 10th day? What do you think? Is this class head data dollar a doesn't show? Then comma 20. You might check class. These are the 20 prices. Okay. Okay. So Control C, average. We have to. Okay. Wait. Let me see if we can use the average function. Average. Check. I'm not sure about this. Head. Okay. Of your data dollar Apple close and then 20. Okay, I'm getting the average of my data Apple close in particular and then the 20, see if it will run. Okay, it did not allow, no? Hindi niya pinayagan yung average. Ay, sorry. Mali, sorry. I used the wrong, should be me. My bad. Okay, 27.66038. Okay, look at this class. So what happened here? you get the average of the first 20 observations, right? Here, mean of, we get the first 20 observations of Apple close, okay? Get the average of that, and then the value is, okay, 27.66038. And you notice it was placed on the 10th. Why on the 10th? Because you're putting it between 1 and 20. Okay, we place it between 1 and 20. So you notice here, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they place it on the 10th. Okay, and then you can check also for the next one. Okay, so I hope we were able to verify that indeed this is actually your SMA 20, only that it was placed in the middle of 1 up to 20. Okay. And notice that it will have NAs at the end. Okay, it will have NAs at the end. And so, okay, the addition of features class will create NA values. So we will have to address that. Next meeting, we're going to address this, because if we're going to use this feature MA20, okay, we have to clean this first. We cannot make use of MA20 in order to predict your price, because there are NA values there. Okay, so this is one step that we will have to deal with. All right, so let's go back here, and okay, so this is our first observation. Then we take a look at another feature, RSI. Okay, RSI. The RSI has its purpose. It's a momentum oscillator. Okay, it measures the speed and the change of price movements. Okay, it allows us to determine whether your stock is overbought or oversold. Okay, typically we use a 14-day period. So this is the formula for RSI. I don't know why it's not working here. I'll just, let me see. I'll create a new RMD file. Hopefully it works here. Work in my file. But I hope class you got it. Okay. It's just 100 over, okay, 100 minus 100 over 1 plus RS. Okay. This is fraction, 100 divided by 1 plus RS. Let me close this. And I gave this other formula. Okay. We have the fraction of average gain divided by average loss. Okay, so what we're going to do is use another feature, RSI, and we're going to add it to our data. Okay, so RSI typically ranges from 0 to 100. And how is it interpreted? When RSI is above 70, it means that the stock could be overbought. So if it's overbought, then it means that it's a potential sell signal. When the RSI is below 30, okay, it means that the stock is oversold. Okay, then it's a potential to have a buy signal. Okay, so useful siya in detecting reversals. Okay, so that's why it deals with direction, both direction and momentum. All right, so how do we create RSI? We use the RSI function. Okay, so this is coming from TTR, technical trading rules, or in R. And then you still we're using data, $RSI 14, which means that we're going to include this object, this this value, this variable RSI 14. Okay, and the date, the function is very easy, just RSI. What's the data? Data dollar upper close. So which means this is the basis. Okay, not the opening high low, not the adjusted price, but the basis for the computation should be Apple, the closing price. Okay, then let's run this. There. Sometimes my computer reacts very slowly. Okay, so there we go. We now have, let's take a look at our data again, data. And we now have this RSI 14. Okay, so we added another feature, RSI 14. And you can see here figures 57, 57. Okay, so we say that the general rule is, okay, when your data breaches the 70 level, that means the data is overbought. Okay, overbought means it's time to sell, potential sell signal. On the other hand, if it's below 30, then it means that your stock is oversold, then it's a potential buy signal. Okay, this ones we can also use for, I handle a subject in masters, and it's called trading signals in well, we use R, and these are the things that we make use of, and we make use of several metrics, not only MA, RSI, also Bollinger Bands, etc. All right. So I gave you some comments, class. Okay. So how do we interpret the MA20? Okay, we will plot this and the RSI. So what we have done was to create this to create the object, right? The object MA20 and RSI 14. Okay, let me pause for a while, and maybe I'm going too fast. Were you able to create the feature MA20 and RSI 14? Okay, good. Thank you. How about the others? Okay, a few more seconds for the others to give their feedback. I'm afraid I might be going too fast, so I'd like to pause. How about the others, please? Okay, all right. Thank you. Okay, so let's first, uh, we have run RSI. Okay, now it's helpful to plot. Okay, let's plot the closing prices. The closing price, the MA. So here it will join. We'll have one plot here for closing price and MA. Okay, we're going to use GG plot. Okay, so for those of you who are not so much familiar with GG plot, uh, it just, so here we're using data, and then this one, the aesthetics here will just identify what are the x-axis, x and y-axis. So here, aesthetic x is equal to the index of your data. What's the index of our data? The index of our data is our time, right? Date, our date. So it says that on the x-axis, what we should plot is the index of data, which is the time, okay? All right. And then you add a geometric line for the MA20, and you put the label, Apple closing price and 20-day moving average. Okay, your X is equal to date, and your y, the label for your x will be date, and the label for your y will be price. And then ggplot has different themes, and it just asks us to do the minimal thing. Okay, so let's plot this class where we combine the closing price and MA20. Okay, control enter. Okay, let's see. Plot. It's running now. There you go. Okay, so what do we have here? Okay, in our code class, okay, the geom line, the red is your MA20, okay, and your apple close is your blue. Okay, you can see it here, class. Geom line, apple close is your blue, and geom line, your your MA20 is your red. So where's that? MA20 is your red, okay? And then you notice here that it's not really very apparent, okay? But let me try to see if I can point that out. Okay, you notice here that they do not begin at the same time. Why? Because when we computed for MA20, the data was placed on the 10th, right? On the 10th day. So you can see here that our Apple close started ahead of MA20. Okay, you can just see the difference between the red and the blue one. There's a gap here in the red one. And also, at the end, didn't I point out to you that your MA20 will have missing values at the end? Okay, because you don't have anymore enough 20 figures, okay, to compute for the average. Okay, so it will stop when you only have 19 figures. You only have 18. So that's why there's a gap at the end. Okay, and that gap is this one. But you can see here how your MA20, okay, is able to follow your stock. Let's see what will happen. Wow, time flies so fast. Let's just experiment and let's say this is let's say a 60-day moving average. Okay, 60-day moving average. Okay, here I'll change this again later. So it's still uh, I'll run this first. Okay, anyway, this is just a name. So 60. And then if I check data, okay, you notice now that it's on the 30th, okay? Because this is a 60-day moving average. So it adjusted 60, and then it split it into two on the 30th. It began the 60-day average. Okay, and if we plot this, okay, if we plot this, let's just plot this one. Okay, so this one, this 20 now will be actually 60, right? Control Enter. Then let's take a look at the plot. Okay. So this is now on the 60th, 30th, a 30th day. All right, so let me undo that. Control Z, Control Z. Okay, back to 20. Okay, it's time. Okay. So just this last one class, just plot the RSI, Control Enter. So this is your RSI. Okay, notice your 70 and this is your 30. Those portions that are above your 70, they are your overbought, which means sell, signal to sell. Those below 30 are your oversold, which means buy. So the suggestion is to take buy positions here. The suggestion is to take sell positions here. Okay, and then just this last one. Okay, there's a okay, we can combine this into one plot, but it doesn't look good. Okay, so let's run this. Control Enter. It's not there. So we placed in one plot. Okay, but it's really not good. We can't really it just superimpose your RSI and your this is your Apple, but better here class is your chart series of from quant mode. Okay, if you run this, then you can see here in one plot you have your Apple price, you have your this is your moving average, and this is your RSI. So this is one very powerful feature of the chart series function from quant mode. All right. So next meeting class, we haven't started the, okay, this is supposed to be the decision tree. Okay. So may I request you to please try to run this here. This will be our first model, decision tree. Okay, and then we'll see how good your decision tree, your random forest, and perhaps we're going to reach SVM model next time. Okay. So let me stop recording now.